Okay, alright, so welcome to chapter 10, okay, which is about wave properties of particle. Okay, so over here in a photoelectric experiment, example 10.1, okay, you have a light source, okay, wavelength 550 nanometer, incident on a sodium surface, okay. So this is the wavelength given over here, okay, incident on a sodium surface. They wanted to determine the momentum and energy of a photon, okay. So the constant value of C and Planck constant given. Okay, alright, so for the solution, okay, so wavelength given, okay. So over here to solve the problem we can use the Broglie equation, okay. Lambda is equivalent to H over P, okay, H is constant, so just determine the value of P, okay, which will be the momentum, okay. So just replace in, okay, so final answer you will end up with 1.21 lah, okay, times 10 to the power of negative 27 kilogram meter per second, okay. And then energy of photon, okay, we can use the equation Hc over lambda, okay, where H is constant, okay, C is constant. So lambda is already given at the equation, so we can determine the amount of energy. So over here it will be equivalent to 3.62 times 10 to the power of negative 19 joule. Okay, now let us look into example 10.2. Okay, so 10.2 we have to calculate the de Broglie wavelength, okay. When you have a jogger, okay, mass given 77 kg, runs with a speed of 4.1 meter per second. And then we have an electron, okay, mass given, moving at the velocity, okay, given, constant H is given, okay. So for the solution, okay, the value given, mass, velocity, okay. So by using the de Broglie wavelength equation, lambda, okay, H over mv, okay, so H is already given, just replace in lah, mn over v. So which will end up with, okay, lambda 2.1, okay, times 10 to the power of negative 6 meter. So repeat the same process for electron, okay. So be given and given, so replace in the value, so final answer you will end up with the lambda lah, okay, which will be the wavelength. Okay, so next, okay, example 10.3. okay, so this one you have an electron and a proton, okay, have the same speed over here, okay, so both moving with same velocity, which has a de Broglie wavelength, okay. They wanted to explain lah, okay. So this one we have to refer to the equation, okay. So velocity constant, okay, lambda will be equivalent to H over m, right? So v constant, so that means if we rearrange and then rewrite the equation, lambda will be equivalent to, okay, 1 over m times H over v. Okay, so H over v will be constant, okay. So that means your lambda will be affected by m. So as the mass increase, lambda will decrease lah, okay, it will be inversely proportional. So over here we can make a conclusion lah, okay, wavelength is inversely proportional to the mass. So electron is lighter than the proton, so therefore electron has a longer de Broglie wavelength lah, okay. And then B, they wanted to calculate the ratio lah. So ratio, so just rearrange, okay, in terms of lambda E over lambda P, and then replace in the values lah, okay. H constant, okay, you can cancel off, okay, V constant cancel off, so it will become a ratio of 1 over mass of electron over 1 over mass of proton lah, this one, okay. So rearrange, final we will end up with mass of proton over mass of electron lah, okay. Okay, so for with final answer, okay, so ratio you get 1833 lah, okay. So 10.4, okay, this one you have an electron accelerated from rest through a potential difference 2000 volt, okay. So this one they wanted to determine the de Broglie wavelength. Okay, electron and photon has the same wavelength. Okay, given 0.21 nanometer. Okay, so they wanted to calculate the momentum and energy of the electron and the photon. Okay, so over here, mass of electron given, charge electron given, C given, H given. Okay, alright, so for the solution, okay, based on the given information, okay, we given, so we can apply into the equation. Okay, so where EV will be equivalent to the kinetic energy lah. Okay, alright, so V is the potential. Okay, so determine the value of lambda. Okay, so this one will be the de Broglie wavelength. Okay, so for B, okay, so since they have the same wavelength, okay, so we can calculate the momentum. Okay, momentum of the electron. Okay, and its energy we can calculate from the kinetic energy equation lah. Okay, half mv square. Okay, and since v will be ratio of momentum over mass lah. Okay, so we can determine that. So replace in. Okay, so find the final value, which will end up with 34.3 eV. Okay, and then for photon, okay, since photon doesn't have mass, okay, so the amount of energy carried will be equivalent to hc over lambda lah. Okay, or equivalent to hf. So this one from the previous chapter. Okay, amount of energy, so which you end up with 5919 eV. Okay, so for example 10.5, okay, so this one they wanted to compare the de Broglie wavelength of an electron and a proton. Okay, if they have the same kinetic energy lah. Okay, so kinetic energy equal. Okay, so now what they wanted to do is that compare with lambda. Okay, so since kinetic energy will be equivalent to EV lah over here. Okay, so we can replace EV, which is equivalent to K. Okay, simplify the equation. So same amount of kinetic energy. Okay, so let's say we arrange in the terms of ratio of wavelength. Okay, so final answer for the ratio we will end up with 42.8 lah. Okay, so this is a very short chapter. Okay, so we only have 5 example over here. Okay, so go through and you can try with tutorial lah. Okay, alright, thank you.